Hello, I'm on site here at Embedded World 2026 and I'm delighted to once again be joined by Frederik Dostal, who is a power specialist at Analog Devices. Now today we're going to be talking about ADI's toolchain to develop power management solutions. But before we dive into that, Frederik, welcome back. How are you? How have you been?
Thank you so much. I've been great. I hope the same is true for you too.
Yes, very well, thank you.
Fantastic.
So for those who haven't seen our previous interviews, why don't you introduce yourself and introduce Analog Devices as well?
Yes, absolutely. So my name is Frederik Dostal. I'm a subject matter expert for power management working for Analog Devices here in Europe. And I support power management technology when it comes to customer questions, but also I do trade shows like here today, and I write technical articles.
Fantastic. And tell us a little bit about Analog Devices.
Oh yeah, that's right. So I do work for Analog Devices. And to be precise, what does Analog Devices really do? So Analog Devices empowers the intelligent edge with the most innovative analog, digital, and software solutions, accelerating breakthroughs that benefit society and the planet. That's what you would find on our website. To most of our customers, Analog Devices is known as a semiconductor company.
Fantastic, excellent introduction. Okay, so let's dive in. So how does ADI view the overall role of its power management toolchain in accelerating customer design cycles? You know, what gaps is it trying to fill?
Yeah, so a tool chain when it comes to power management is extremely important. When I started working in the industry a long time ago, almost 25 years ago, we slowly started developing spreadsheets and things like that. But for the most part, we used a pen and paper. Mm-hmm. And that took a long time and required a lot of expertise also. And now we have tool chains in the industry, and Analog Devices has quite a nice tool chain available that is covering everything from the first design ideas all the way through let's say practical measurements and evaluations in the lab with hardware. And all the steps in between are covered with the tool chain. And what it really helps is that many of our customers, let's say, don't have enough expertise when it comes specifically to power supplies. You know, Paige, everybody needs a power supply who does electronics, but not everybody necessarily earns their bread and butter by designing power supplies. They just need it. It's a necessity, right? Yeah. And so some companies have power management experts, others don't. And the problem really is to attract that talent. And so we see that in most companies have a lack of power expertise or not enough power management people. And that translates directly into a time problem because they have deadlines with their projects. And then if the power management, the DC to DC conversion and so on is missing, then the whole project is delayed. Yeah. And so this is really where the tool chain comes in to help speed up the design process of the power supply and to really optimize the power supply. There are many power supplies in the industry that really don't work all that well. And the reason is that probably there was not the expertise necessarily available at that time, at that company, building that power supply.
Okay, that makes sense. So let's dive into some of these tools.
Yes.
So let's start with LT Power Planner. Where exactly does that fit in the early stages of designing a power system?
Yeah, so the LT Power Planner is something unique. I don't know of any other tool in the industry that does exactly the same thing. So that's a tool that you start out with. Because before you actually design one DC to DC converter, for example, you need to first decide what kind of power architecture do you want to do. And by architecture, I don't mean the topology like a buck or a boost. I mean, maybe you have one input voltage and you need 10 different output voltages. How do you connect these output voltages? How should the architecture look? So you have to focus on a block diagram to decide, I'm generating from a 24 volts on the input, first an intermediate voltage of 12 volts. And then I'm taking these 12 volts, converting them to 5 volts to 3.3, 1.8, and I'm using a linear regulator to convert 1.8 to 0.8 or something like that. So that architecture can become quite complex. So typically you have maybe 10, 15 blocks. And then it becomes really hard in your head to make all these decisions without actually drawing it down. And so the LT Power Planner is a tool, it's a block diagram drawing tool, but the additional value is that you also can calculate the total power efficiency by assigning different efficiencies to each block. And then the tool calculates, so the whole power architecture, consisting of 10 voltages maybe, has a total efficiency of 75.7%. And this is something you cannot do in your head just intuitively, right? You need something to calculate that and also to draw it down. And this is really where the LT Power Planner comes in as the very first step before you zoom in to one DC to DC conversion then at a time.
Okay, excellent first step. So next up we have LT Power CAD. So how would you describe that one?
Yeah, so LT Power CAD would be the next step, as you said.
Yeah.
And there we zoom into one of these blocks and then say, well, this block is supposed to do, let's say, a 5 volt to a 3.3 volt conversion at 5 amps of output current with a certain efficiency. And then we would like to know what kind of external components to the integrated circuit, so what kind of inductor, what kind of capacitors, what kind of resistors are necessary for an optimized design. And this is what LT Power CAD does. So LT Power CAD is a circuit calculation tool. And proposing an optimized solution, a user can then still make slight modifications as they please, but otherwise the tool really proposes something. And this is important for electronic designers that are not necessarily power experts. If designers are power experts, they still use the tool in order to modify certain things and then just do the calculations to see how fast is my regulation loop, how well does the power supply react to line and load changes. And the advantage really is it's super fast because it's not a circuit simulation tool, it's actually a circuit calculation tool. That might sound very similar, but to calculate a solution means just some formulas are being used and you get results super fast. Doing a simulation, typically it's a time-based simulation, depending on what you simulate, might take much, much longer. So there's a difference, and you start off with LT Power CAD with the circuit calculation first.
Fantastic. Well, next up we have LT Spice, which is obviously widely used across the industry. But in simple terms, can you explain what it is for us and what makes it essential?
Yeah, so LT Spice would then now be the circuit simulation tool. And when you step from your first design idea from LT Power CAD onto LT Spice, there's a button actually you can just push, and then it exports the LT Power CAD design into LT Spice. And then in LT Spice, you can do a simulation in the time domain with it. Theoretically, the simulations of LT Spice, the simulation results, should be the same as LT Power CAD as the circuit calculation. However, when you do a time-based simulation, you can, let's say, also look at additional parameters, like add filtering to the design, or you can tweak certain parameters where LT Power CAD might not let you tweak those parameters. So in LT Spice, you're just totally free. You can do whatever you want. It's a complete circuit simulation tool. And coming back to your real question, specifically, you're asking if how it really helps the designer. And it really helps by giving a circuit designer, let's say, the confidence that a design, once it's built in hardware, actually does work and really works well according to what they saw already in the simulation results. So we have a lot of users for LT Spice. It's a huge users group, not only in the power domain, but when it comes to analog simulation. So it's a very attractive tool. And in the power domain, it's very helpful. So I use it every day in order to help customers find solutions, and also for myself to just check, does this actually work or doesn't it work? And I try to think hard about these problems, but then usually just doing a quick simulation answers so many questions so that it's really valuable and relatively easy to use, I would say.
Okay, and what about LT Power Play? So that's up next. How does that help engineers?
There's so many different tools. It must be confusing for the users, but we're trying to do a good job in combining these tools so that a user is actually taken from step 1 to step 2 to step 3 and step 4. And step 4 would be the LT Power Play. And LT Power Play is a separate tool. It does not simulate, it doesn't really calculate either. It's just an interface tool for digital power supplies. So we have many different power supply products, of course, and some of them have a digital interface. And with that digital interface, that can be I2C or PM bus, which is based on I2C. And these digital interface, you have to talk to them somehow.
Yeah.
And in mass production, you would have a microcontroller on your board talking to these power supplies, telling them what to do specifically. Yeah. But when you evaluate such a system with a digital power supply, it's kind of nice to have a graphical user interface tool to actually talk to the power supply, make changes, change settings and so on. And then you can also read information off of the power supply with the digital communication, and then within LT Power Play, you would get like a scope window to see what the output voltage is like. You can change the output voltage around. You can define things like if the integrated circuit gets too hot, what should it do? Should it shut down? Should it retry after a certain amount of time? And all these things. So when people use digital power supplies, LT Power Play would be the tool to use to talk to it, to evaluate it, and to actually see what's going on during the development process.
Fantastic. And last but by no means least, we have LT Power Analyzer. Can you explain that one?
Yes. So LT Power Analyzer is our latest addition to the tool chain, because we have realized all of these tools are really good, they work well, they are helpful, but at some point you have to build hardware and evaluate the hardware. And that is a little bit of a challenge, because typically, to evaluate a power supply, you need a lot of different equipment. You need, of course, an oscilloscope, you need an electronic load or some kind of passive load on your lab bench, you need lots of multimeters, and so you have to invest a lot of money. And especially what's also important is, in order to plot the loop response, the transfer function of the regulation loop of any power supply, you would need signal analyzers and network analyzers to do that. And they're typically quite expensive. So what we have released now is the LT Power Analyzer, which is a complete power management evaluation, system setup. And that setup comes with a software, and in that software it's very easy to plot efficiency of a power supply, to plot the regulation loop, the Bode plot of a power supply. It does load transients all the way up to 100 amps, which is of course a lot of current, and it can all do that with a low cost, easy to use small setup that almost fits in your pocket. So I carry my LT Power Analyzer from customer to customer, because in case they don't have it, I can come in, do all these measurements, and then they're happy with the results. And at first we had this just as an internal tool, but roughly a year ago we started selling this to everybody. So you can look up the LT Power Analyzer on our website.
Excellent.
And everybody can order it and then work with it, do the actual measurement of the power supply, and then they can take the measurement results and actually within the software compare it to a calculation result from LT Power CAD and compare both with each other, which is also interesting, because then you have your real evaluation, your real measurement, and you can easily compare it to your calculation and see where differences are, or if it matches perfectly.
So how do you see all of these, how do they complement each other as a whole?
Yeah, so as a whole, the goal really is so that they work hand in hand with each other, all of these tools. That's really the idea. And it works quite well, so that we are closing the loop, so to say, that the measurement result can be compared to original simulation results and calculation results. That's really the way it works together. But I do see also in the future that these tools will interact with each other even more than they do today.
Yeah.
But already today, it's all from one vendor, from us. And especially the software is all free to use. You can download the software. Even with the evaluation tool, the LT Power Analyzer, if you don't purchase it, you can still download the software for free and play with it and see what it can do.
Excellent.
So it's a very open resource, I would say.
And I mean, you've already touched on it, but what would you say are some of the most common bottlenecks in power system development today, and how does your tool chain help solve those?
Yeah, so the bottleneck really is expertise, I would say, but combined with the development cycle time. And the problem really is every company really, or most companies, have to develop things quicker, faster. The world is changing quite quickly. I know my parents said that 30 years ago, 40 years ago, but it's still the case. So, which means, especially in the power development, which usually isn't really the, let's say, the unique or the specialty of a design system, right? It's just, I touched on it earlier, it's just a necessity that has to be there.
Yeah.
So customers or users can just not afford to spend a lot of time on that. And really, I think it's the time and the expertise that make these tools absolutely necessary. And I think if we didn't have these tools, it would be quite hard to sell power management solutions.
Yeah, definitely. And are there any particular sectors that are pushing the hardest for these advanced power design tools?
Oh, this is a very good question. I would say it's all over the board.
Yeah.
At first I thought, well, maybe the sectors, like maybe, aerospace and defense, or some sectors, or instrumentation, that rely a lot on our micromodules. Micromodules are these all integrated products that have inductor and capacitors and things, external components, all integrated in the device. Typically, they're easier to use because everything is integrated. We think of the circuit and the users just have to solder it onto their board in the best case, right? So I would have thought maybe these customers don't need the tool chain as much as customers from other segments, as you say. But then we noticed, especially our micromodules are simulated with and are calculated with an LT PowerCAD and LT Spice quite heavily. So even such customers where you would think, oh, they have an all integrated power supply they just buy, they still do the simulations to make sure the power supply works quite well within other things on their board. So really, I would say it's completely all over the board.
Okay,
Well,
I can tell you're definitely excited about this tool chain. So thank you very much for taking the time to explain it for us, and I hope you enjoy the rest of the show.
You're so welcome. Thank you so much, Paige.
You're very welcome.